Hello, everyone. Thank you for joining us, and welcome to today's webinar, Learn How ENVI Opticalscape will take your digital surface models to the next level. My name is Jody Lee, and I'll be the moderator on this webinar. I'm excited to be joined today by Bill Akubo, Product Manager for Opticalscape at Harris Geospatial Solutions. Also, I'm joined by Loris Copa, Earth Observation Specialist at SARmap, and Alexandro Cattaneo, Earth Observation Engineer at SARmap. Just a couple of housekeeping items before we get started. I've muted the phone lines for all attendees, so if you have questions at any point during the webinar, feel free to enter them into the questions chat box, and we'll try to answer as many as we can at the end of the presentation. We are recording this webinar, and we'll have it up on our website at www.harrisgeospatial.com in the next couple of days. We'll also email you a link to the recording as well as the slide deck, data sets used in this webinar, tutorials, and maybe some other stuff. So you're welcome to share these with your colleagues. So now I'm going to turn things over to our first presenter, Bill.
Thank you. Hello, everyone. So for the agenda today, we're going to do a quick overview of Harris Corp and SARmap. And then we'll do an introduction of Opticalscape, and then we'll dive into both of the modules, the Spaceborne module as well as the UAV module in a little bit more detail. And Loris and Alessandro will go through that. And then we'll have some application examples and then time for questions and answers at the end. Okay, next slide. So Harris Corporation is a global leader in communications, electronic systems, and space and intelligence systems, and we're based out of Melbourne, Florida. We have almost 8,000 engineers and scientists with customers in over 100 countries worldwide. Next slide. So at Harris, we offer end-to-end solutions of data and imagery onto software and technologies and tailored services. For the data and imagery, we fly our own Geiger mode LiDAR sensor, and we resell other imagery and derived products through our MapMart and ImageLink services. And then our software includes ENVI, which is a remote sensing image processing application. It has modules to it such as SARscape and Opticalscape. IDL is the language that ENVI is built on. It's a data visualization software. For enterprise deployments, we have our Geospatial Services Framework, and for UAV and aerial type collect data, we have Precision Pass, and that's a tool to help you actually review and check your data collect before you actually go to the processing step. For our D&I customers, we have Jaguar, which is a data management and dissemination system. And then we've delivered a lot of exciting technology using deep learning for geospatial data. In terms of full solutions, that really is the big piece of what Harris brings to the plate. Our primary market for solutions is defense and intelligence, and we also have significant customers in federal and civil government, utilities, agriculture, and transportation are some of our fast-growing solutions areas. Next slide. So SARmap is really known as the developer of SARscape. SARscape is a SAR processing module that's integrated in with ENVI, and now Opticalscape. The company was formed in 1998 by SAR experts who really spun off from the University of Zurich in Switzerland. They've provided algorithm and software development and remote sensing services to global organizations like the European Space Agency, World Bank, and Japan Aerospace Exploration Agency. Next slide. So what is Opticalscape? Just at a very high level, it's really a module, series of modules, Spaceborne or UAV modules to ENVI and it's really intended to generate DSM and orthorectified images from those modalities of imagery. It has a number of high-level capabilities. It's fully integrated into the ENVI toolbox, so that really means, like SARscape, you have sort of a guided processing to take you through the steps to use Opticalscape on your imagery. It has a unique capability to fuse the processing of optical and SAR data for greater DSM accuracy. And then, like ENVI and SARscape and much of our capabilities into the future, a real advantage of the software is that there is a language, an API, so that you can actually automate processing workflows. Next slide. Okay, so this is our poll question here, and yeah, Jody, you want to talk to that?
Yeah, so I just launched our poll question. So what type of geospatial imagery do you use? Select all that apply. So satellite, stereo pair, UAV, SAR, planning to use these in the next 6 to 12 months. So select all that apply to you. And we'll close the poll in about 2 seconds. Okay, so it looks like 60% are satellite, or use satellite. Next is 20% use UAV, 15% use stereo pair, 0% use SAR data, and then I can't read the last results. 5% use planning to use these in the next 6 to 12 months.
That's great, Jody. Thanks. That's pretty much what I would expect. I'm surprised to see there's no use of SAR data yet, but that seems to be growing, and especially with availability of a number of SAR satellites out there that provide data for free, actually. So, and the UAV market is growing for us, so it's nice to see that coming up in terms of a percentage. So from here, I think the next section, I'll pass it over to the folks in SARmap.
Hello, I am Loris. I work with SARmap, and I'm one of the responsibles for Opticalscape. As Bill said, Opticalscape is a modular collection of functionalities supporting digital surface models and orthorectification of both Spaceborne and UAV, which are the two main modules. And we also provide a third multi-purpose tool module, which includes all the functionalities needed to, for instance, apply geodetic transformations, resample data, and so on. All the products generated with Spaceborne and UAV modules can be used within SARscape, which is our main software, specifically in the basic interferometric and interferometry stacking modules, which we will see later. And this enhances to enhance the quality of the synthetic aperture radar products. Also, being both in ENVI structure and SARmap structure, our products can be used further in ENVI, for instance, with the LiDAR tool and or for topographic transformations, classifications, and so on. The Spaceborne module is made in order to support all the major commercial available platforms. And we plan to add them every time there is a new one which is available to the public. We provide inside of this module all the tools needed to generate the DSM and to orthorectify images. In order to simplify what is the process to generate a DSM with the Spaceborne module, we provide two main steps to follow, which are one, a dedicated import routine for all the platforms, which will simply import the images, convert the metadata in our structure, and apply some image enhancements in order to improve the matchability of the images. And secondly, we provide all the steps needed to produce a DSM in one single workflow. We also give the possibility to run each of the processing steps separately for more advanced users. For importing images, it's as easy as finding your metadata. As you can see, it's divided for every single sensor. And we will ask to give the metadata or the tile files or what is needed according to the platform for the triplet or stereo pair that you want to import, and to specify an output folder. Then you simply have to click next, execute, and those images will be converted in our structure. The second step is the generation of a digital surface model. Here you simply have to choose your files that you have imported, specify your output cartographic system, your output pixel size, and then click next, which will guide you to the only step that requires a user interaction with the software, which is the ground control point selection. We suggest to use ground control points in order to have a higher precision of the outputs, but you can also use only type points. For the Spaceborne component, we do not have at the moment an automatic type point extraction tool, but this will come in the future. The tool asks you to choose even the only one file, and then if the files are all in the same folder, they will be put in the correct order automatically by the tool, and then you simply have to click next. You can choose an optional DEM file if you want to, for instance, give just the latitude and longitude coordinates of the point and then extract the elevation of the DM at that point. Or alternatively, the standard DEM that comes with ENVI, with the GMTD 2010, will be loaded under the images. Then it's simply a matter of selecting one point in one image, and then it will be reprojected in all the images composing the stack, and then adjusting them manually, because these points are needed to correct the rational polynomial coefficients, which are the functions, are basically the connection between the geographic space and the image space, which can be rather relative than absolute. So there might be some shifts compared to the reality. In order to select type points, you simply have to right-click on one of the points that you placed on the images and toggle it to type point. In this case, the geographic information of the point will be completely discarded. For ground control points, for instance, this is one of those that we have obtained for these images, and it's one crossroad, easy to identify and to put in the images. And then simply click next, and this will be the result, for instance, for this dataset. This is a Pleiad 1A tri-stereo dataset. The output you see here is a raster, which is provided by default by the software, and also there is a point cloud, which is in both LAS file, which can be opened by the leader module of ENVI, and also a shapefile, which can be opened by pretty much any GIS around. The second part is the possibility to produce the orthorectified images, which are images projected in geographic space. In this case, we do not provide a workflow for now, and it simply uses a few of the steps that were needed for DSM module generation and put them in 4 separate steps. You have to import the images again in order to place the metadata in our in-house structure. Select the ground control points or type points again. Unfortunately, because of the ground sampling difference in ground sampling distance and rational polynomial coefficients, we do not usually translate the ground control points collected for panchromatic images for the multispectral ones. Apply the rational polynomial coefficient correction, which is a way to have a higher accuracy in the output. And finally, run the auto image generation, which can be done using the DSM that can be generated with Opticalscape using an external DSM or DEM. And also, finally, if someone doesn't have any of these information, even a constant height. Again, you simply have to choose your metadata, specify your output folder, and it will be populated by the imported images. The ground control points work exactly as before, only this time in multispectral images. And this is an example of why we can't directly reproject the points on the multispectral images. As you can see, the ground sampling distance is quite different, and also the rational polynomial coefficients may have a different calibration. Finally, you can correct the rational polynomial coefficients with 4 different algorithms that we provide. Each one of them requires a different kind of number of ground control points. It is specified in the online help how many are needed for what type of correction. And finally, we can launch the orthorectification of images by selecting the input candidate that we want, for instance, in this triplet. We chose the nadir one, which had less shadows. Either specify the cartographic system or select the DSM that we just generated, and then obtain our orthorectified image. We have talked about the fact that we can use Opticalscape in conjunction with SARscape. This is an example of what can be done in the basic module, for instance, which is georeferencing of Cosmos SkyMed images. We can do it, for instance, using an SRTM digital elevation model, which is free to use. But the resolution of this digital elevation model is quite low. So, for instance, on the right image, we have used a 90-meter one, and we can see that there is a noticeable deformation of the features. In the center one, we use the 30-meter one, which has even more deformation of the features, while on the left side, we used 1 meter Playard stereo DSM in order to correct it, to georeference it. And as you can see, the features are very much more linear with less distortion. Also, what can we do with these images? With SARscape, we can generate interferometric DEMs, and with Opticalscape, we can generate DSMs from stereo imagery. We do collect the information, which you can see below the 2 DSMs, that explains what part of a DEM can be used in conjunction with the other one. As you can see, one is white, the other one is black, exactly at the opposite of the other one. By doing so, we exploit the main points of each one of the 2 platforms to obtain a better DEM. Also, we can do something similar with the use of optical DSMs in conjunction with SAR imagery to improve the detection of land displacement. As you can see, this is a mine example, and the one on the right is a land displacement map. derived with Cosmos KMed. Without the optical imagery, we would not have been able to detect these displacements.
Thank you, Loris. Hello, everybody. I am Alessandro, and I'm the responsible for the UAV Opticalscape. Opticalscape UAV provides the possibility to generate digital surface model, point clouds, and orthomosaic images. The image format supported are JPEG, TIFF, multi-page TIFF, and single-band TIFFs. The images must be geotagged, and the GPS information must be stored in the EXIF metadata. The sensor pixel size and camera focal length, if not available in the EXIF metadata, must be known by the user, and attitude angles are optional. Images must be acquired in a photogrammetric way. This means that the overlap along the track must be at least 80%, and across the track must be 65%. If these conditions are not satisfied, the software will open a warning pop-up. The processing chain can be divided in 3 main steps. The first step is a creation of a project file and several meta files that are needed for the further steps. The second is the generation of the digital surface model. Can be done either with or without ground control points. The third and last step is the generation of orthomosaicing. Let's have a look to the interface. This is the first panel, and it's just enough to select the input image data, and the software will populate automatically all the information needed, such as UTM zone, hemisphere, sensor pixel size, focal length, and so on. Then it will be enough just to click start, and all the meta files will be generated. These are an example of what files will be created. And it will be also created an image location file in shape format just for visualization purposes. This is the second step, and I can skip to the workflow with GCP since it implies 2 additional steps. Okay, this workflow is composed by the first step is the data import and preprocess. And it's just convert the input images to the SARmap format. It is possible to correct images from distortion. And in case of multispectral images, it is possible to co-registrate the bands to align each band together. And the second sub-step is the type point extraction is completely automatically. And those type points will be used in for the bundle adjustment. That is the orientation and the positioning of cameras plus calibration of sensor. Then the workflow will stop automatically to the GCP selection. The user will have to click on select GCP, and the GCP interface will be open. On the left view, it will be open the image composite with all the images composing the dataset reprojected. And on the right view, it will be possible to see the hit image. The first thing to do is to place the points on the left view and to correct the map X, map Y, and ellipsoidal height for each point. Then the second thing to do is to click on each hit image and to refine the position of the reprojected point for each image and for each point. Once everything is done, it's enough to click finish and to go on with the workflow, and this will be the result for this dataset. It will be DSM in a raster format and also a point cloud in a LAS format. The third step is the orthomosaic. The user will have to select the project file, then the DSM file name that will be the same DSM that we just generated in the previous step. Then we'll have to select the input images, one list for each band. And these images will be found in a subfolder called orthoproducts /R or G or B. Let's have a look to some parameters. The main parameter is the mosaic type, and we have three types of mosaic. The first one is the optimal resolution approach that is suitable for agriculture or vegetation scenarios. The feathering mosaic that is good for man-made or urban scenarios. And the third one is a simple last pixel. The orthomosaic grid size will be calculated automatically, but still the user will be able to modify it manually if he wants. And this is the resulting mosaic. It is a raster as well. This is an example in 3 dimension of the same mosaic. And this is an example of the integration between the UAV and the SARscape interferometry stacking. We generated a very high resolution DSM with the UAV data, and with SAR data we generated a land displacement map on the right, you can see. And I'm done. I leave to Jody. Thanks, everybody.
Great. Thank you, Bill, Loris, and Alexandra for the informative presentation. I did want to say apologies for the poll question earlier. I heard that people could only select one answer rather than multiple, so sorry about that. At this point, we're going to address some of the questions that have come in. As a reminder, you can send us your question using the questions chat box in the GoToWebinar dashboard. So a few questions have come in. The first one, are GCPs mandatory?
Well, GCPs are not actually mandatory, but a minimum of 3 type points has to be provided to the DSM Generation module for Spaceborne. While for UAV, this is not mandatory since we have provided it with a tool that automatically extracts type points. Of course, obviously, if you don't use ground control points, there is a high probability to have a geographic displacement of the results.
Great. Next question. Do I have to select type points manually?
Well, it was partially answered with a previous answer. For Spaceborne, you have to select them manually at the present time, while for UAV, there is an automated module for this.
Great. Next question. What UAV data are supported?
Could you please repeat?
What UAV data are supported?
Okay. They are supported JPEG and TIFF data. Just remember that the data must be geotagged.
Okay. And then another question, can I use oblique images?
At the moment, not, but it's something that we're preparing for the future.
All right. Next question, any plans to utilize SAR in any more UAVs? Is it only used with the predictor at this time? I believe within the air breather asset currently. This guy only works with ravens, but he's curious. Does that make sense? Want me to reread it?
Well, we will have to check about this question and maybe get later answer later to this question.
Yep, that works. See, I don't think so. At this time, we don't have any more questions, unless you guys have any on your end. I don't see any more questions.
No, we don't see them.
Okay, so with that, we're going to wrap things up. We appreciate everyone's attention on the line, and thank you again to our presenters. If just a reminder, we did record this webinar, and so we'll be emailing you in the next couple of days with the recording, the slide deck, data sets, tutorials, and some other information. This recording will be available on our website at www.harrisgeospatial.com in the next couple of days, and we encourage you to share it with your colleagues. So thank you, everyone, and have a great rest of the day.